Hello, everyone. So we have talked from the beginning about the star patterns that ancient peoples looked at and the sun patterns that timed the seasons. And now we're going to talk about the moon patterns, which are probably one of the most obvious patterns in the phases of the moon and the eclipses of the moon. So let's get into it a little bit more. The moon does rotate about its axis, but we only see one side of the moon. Explore that. The moon does revolve around the earth, and by doing so revolves around the sun, and the moon also precesses and wobbles on its axis. So the same three motions that the earth makes are also made by the moon. And you may wonder, well, how do we only see one side of the moon? And this graphic will help you to understand it, and I would recommend that you go and work on this with an object in the middle of your room so you can understand it if you are spatially challenged. But what you're saying is that you will face the model at all times only if you rotate exactly once during each orbit of the object. So it's a very slow rotation as you revolve. I really recommend that you do this one time in your room and you will get it right off the top. This moon of ours rotates counterclockwise and it revolves counterclockwise as well. The rotation period has become identical to the revolution period. It was not always that way, and it's called a tidal pull because the earth effectively pulls a tide, not of water, but a tide of mass on the moon. And over millions of years, that pull has effectively slowed the rotation of the moon down to synchronicity with its orbital revolution. So really fascinating stuff. And you do see it with moons around planets. You can see it with moons of other planets as well, but we have one spectacular just outside of our window every night. I went over that to go over the phases of the moon. This is one of the I like this drawing better. I'm going to cut out the other drawing because I like this drawing so much better. So what I am going to talk about with the phases of the moon, I am going to explain to you about why you sometimes see the moon during the day. And it's really hard to get a good explanation for that, but this is a great diagram for it. Look at the sun and where it's at. Look at the earth and where it's at. The earth is turning counterclockwise, and keep that in mind that the earth is turning counterclockwise so that you come up with the sun rising in the east, you have the sun setting in the west with the earth's rotation. In the middle, there's noon and midnight. Keep that in mind. The moon rotates around the earth and is continually lit by the sun. And in this position right here, the sunlight is on the side of the moon that we cannot see from Earth. You might be a person who's standing right here. You can't see the moon. That is the new moon. All right, that is the new moon. And the moon will revolve around the earth in a counterclockwise motion. So our next step is the revolution moves over here, and you can see a touch of the light from your position right here. And that touch of the light that you can see is the waxing crescent. If you're wondering about why it is on this side, you have to picture yourself looking at the moon and you will see the waxing crescent on the right. Right? Keep that in mind. As you are looking over here, you are seeing one half of the moon. And then you go over here, you're seeing most of the moon. Then the sun shines completely and there's your full moon at midnight. Waning gibbous moons look like the other side. they show up before sunrise. Last quarter moons show up at sunrise. Waning crescent shows up in the middle of the morning. It's a great diagram. Please take the time to look at this and get a good feel for how it looks when you are standing looking at the sun, or when you are standing here at midnight looking at the moon. So you can put yourself in any position here, and that'll be what you are seeing at that time. Now, we talked about the fact that there were lunar calendars, and our calendar now, the Gregorian calendar, is a subset of a lunar calendar. And the lunar calendar can be very accurate. I want to explain to you that there are two ways of measuring time on a lunar calendar. And the ancient people, especially the Egyptians, understood this very well, and I want you to understand it as well. First, there is what we call a sidereal month. We talked about sidereal days, same proposition, that you are aligning with the stars in each rotation. So let's start here where you have a new moon that is not visible by the earth. Okay, the start of the revolution of the moon. And over the course of the month, that moon will revolve around the earth and rotate at the same time. And over the course of that month, the earth will also revolve around the sun. That revolution of the earth is pivotal because the moon can rotate counterclockwise and come back to the same location in comparison to these very far off stars, which are so far off that it looks like you are in right here the same, you are in right here, the same location with respect to the stars. Remember, these stars are so far off that this essentially looks identical to you. That's called a sidereal day, when you have rotated to the point where, go once around, when you have revolved. Once around, you seem to be at the same point relative to the stars. That is a 27.3 day month for the moon. But we don't have 27.3 days of the month for our lunar calendar. We have a longer month. And in fact, we, just like with solar days, do not want to stick with sidereal days relative to the far off stars. We want to stick to our time relative to our nearest star, the sun. And since the earth has revolved and moved about 30 degrees along a 360-degree circle in the 1 month time, remember 360 degrees divided by 12 is about 30 degrees. It is 30 degrees. So you need to go an extra 30 degrees with this moon to get back to the same position that gives you a new moon look. So in doing that, that takes 2 more days roughly for the moon to do. And we have a synodic month, right? From synod, meaning traveling together. You might hear that from a religious perspective in the Presbyterian Church. They talk about synods of groups of people traveling together. And in this case, the moon is traveling with the earth and shows the same new moon phase at 29.5 days. So think about this and look it over. These diagrams I think are a little bit better than the ones in your book. I hope they help you out with that. And I wanted to explain to you that the lunar calendars go back very far. In fact, just I believe in 2011, one of the first lunar calendars was found in the north of England, a place called Warren Field. There was an air sighting during a drought of these 12 pits that you see here. And that 12, whenever you see 12, you're starting to think about lunar months. And they lined it up with the topography of the area and a hill that is right here. And you see this hill right here. And these pits were showing the winter solstice coming right between the V of this hillside, which is noted here by this dark area. So that goes back to 8000 BC. They did quite a bit of excavating on that to look for the evidence of these pits lining up right along the lunar months when the moon would ascend. So fascinating stuff. Lunar calendars go way back, and now we're going to talk about lunar works and eclipses.